Hey guys, welcome back to another video. So in this video, I'm going to be talking about periodicity. It's the first part, sort of periodicity that I'm going to talk about. I'm probably going to do a second part next week. The first thing we have to know about periodicity is, what is it? Periodicity is sort of recurring trends we see based on the periodic table. And so the two I'm going to go over today are ionization energy trends and atomic radius. To put it simply, ionization energy is the amount of energy you need to ionize or remove an electron from an electron shell. An atomic radius is, let's say if you have two sort of atoms, then atomic radius is half of this distance. That's atomic radius. So essentially atomic radius is size, essentially. That's one way we can look at it. So let's look at ionization energy first. So ionization energy, I'm just going to title it here, ionization energy. I'm going to tell you the trend right now. So as you go to the right top corner, it'll be greater ionization energy, and on the bottom left, it's lesser. So basically what I'm saying is, as you go to the side, so let's say like silicon compared to cobalt or something. Silicon will have a greater ionization energy and cobalt will not. Even something close like here, phosphorus will have a greater ionization energy and germanium will have a lower ionization energy. So the left bottom corner and the right top corners are sort of reference points. So anytime you want to compare two elements, see which ionization energy is greater, you can just compare to these landmarks. Now I'm going to give you sort of the reason why this is. So ionization energy is essentially, like I've said before, the energy it takes to ionize an electron from an electron shell. Now, if you look at something like cesium with, let's say you have cesium here, and you see it has a ton of these electron levels. This isn't even all of it, right? I'm not going to draw all of it, but you see all these electron levels, right? There are electrons everywhere. I'm just drawing random electrons at this point. It has all these electrons. And what makes this so easily ionizable is the fact that only close to the nucleus will you see the electrons sort of attracted to it. So these electrons close to the nucleus will be attracted to it. So because it has this electrostatic force, it's going to be harder to ionize, whereas these electrons at the outer parts aren't attracted to this, so it's easier to remove, right? It doesn't take that much energy to remove, and this is a phenomenon known as shielding. These electrons sort of near the nucleus are shielding the outer electrons, and so the outer electrons are easier to ionize. But if you look at something like fluorine, right? Fluorine with such a small number of energy levels, all these electrons are attracted to fluorine nucleus. So these electrons are attracted to the fluorine nucleus. It's really hard to ionize. It takes a lot more energy for it to break this electrostatic attraction. The next periodic trend that we're going to look at is atomic radius. atomic radius. Atomic radius is a lot easier to understand compared to ionization energy. Atomic radius is basically how big the atom is. So it's going to be sort of flipped. Greater and less. This is really easy to understand. So something like cesium, like I mentioned before, which has a lot of energy levels. If you have a lot of energy levels, you're going to be bigger. That's essentially all atomic radius is. Compared to fluorine, which only has, 1 or 2, it's not as big, and that's why it doesn't have as big of a radius. So now let's do some practice problems, because that's always needed. I'm going to sort of give 2 elements, and I'm going to sort of ask, in relative to each other, which has the greater atomic radius or ionization energy. So let's look at, let's say, chromium and molybdenum. All right, chromium and molybdenum. So that's over here. I'm going to ask which one has the higher ionization energy, which one has the greater atomic radius. So these are the 2 trends that we've looked at so far. Okay, let's look at ionization energy. So ionization energy is the amount of energy it takes to ionize. So chromium, which has a lower number of energy levels, right? Because it's 4 compared to 5 in molybdenum. So chromium has a lower number of energy levels, so it's going to have less shielding, like I mentioned before. And because of less shielding, the electrons are going to be harder to ionize compared to molybdenum. So here, chromium has the greater ionization energy. But let's look at atomic radius. Atomic radius is the opposite. If you look at molybdenum, it has more energy levels. With more energy levels, it's bigger. So molybdenum has the greater atomic radius. Now, let's look at one more. Let's do nitrogen and carbon, right? Ionization energy, atomic radius. Which one is bigger? Okay, so let's use the same thought process. Nitrogen, in this case, will have a greater ionization energy. Just because if you look here, it's closer to fluorine. That's sort of our landmark. So, nitrogen. And atomic radius wise, carbon, in this case, just like I mentioned before. Alright, that's going to wrap up this video. Thanks so much for watching, and I'll see you guys next week.